Hello and welcome back to my workbench. We have another job ahead of us here. This is another MacBook Air A1466. I think this is a newer model, 2018, that I bought not working. And I have opened it up and looked inside, and I thought I would share it with you. So I got the screws out. Here we go. This is what I found. Yes. Small amount of corrosion. That's what eBay would call a small amount of corrosion. But yeah, we've got some fun ahead of us cleaning all this up. I do have some parts boards I can pull some pieces off of because I got a feeling I'm going to need it. It does not try to charge. I disconnected the battery. Hooked a power supply to it. It doesn't really pull any current. There's no light. But then again, I think this is the 3.42 supply right in here as best I can remember. So that's probably why it's not doing much of anything. And that Wi-Fi module does not look very good either. So, time to get the board out and see what's underneath all that lovely corrosion. Well, the board is out now, and that's what we saw earlier. And when you flip it over, we have a little bit of something going on around the PC, the SMC. So this could get to be interesting. That doesn't really look quite as bad as the top side, or whatever you want to call the top side. This side looks worse, I think. So just time to get to cleaning and see what's underneath all that mess. Here we are under the microscope after some cleaning, and you can see my aggressive toothbrush cleaning. We have knocked off a few components, like this little transistor right here, which I think goes up here somewhere. And I think I've knocked off some small resistors and capacitors in this area. And well, these didn't get knocked off, but they're going to be like this IC here, which I believe is what generates, along with this coil and capacitor and maybe a diode right here somewhere, generates the PP3V42. And so if that's dead, you're not going to get a whole lot of life out of your MacBook. So I got a lot of cleanup to do in this area. This IC here's got corrosion all under it. I don't know what that is yet. I haven't looked it up. But I did knock a few things off, but I'm not too concerned about that because I do have a donor board, if I can find the same area. Here we go. So I have a donor board here. Well, we should have all that. I don't think I've robbed any of this off of this donor board. I have two of these actually, and I don't think I've hit this area. So that's what it should look like. So we got some cleanup to do. Probably got some trace work to have to repair. But at least we do have the parts. And let's take a look over. Take a look over in this area near where the other damaged area was, around the backlight circuit. This looks pretty rough, and we've knocked some capacitors loose. Yeah, this connector, I don't know if it's going to make it or not. I do have a connector on this donor board. That's looking pretty rough. There's still some green corrosion down in here. I'm guessing this was like a soda, like Coca-Cola, because if you look, let me see if I can get this coil. See that dark spot there? This kind of reminds me of Coca-Cola. Could be coffee, but it looked awful acidic the way it had, blown up. And the battery was dead, by the way, so yeah, the battery dumped all of its power into making corrosion for us on this thing. There's the backlight fuse. Strange enough, I don't think the backlight via is blown on this one. Right down in there. It always dies. It didn't die this time for some reason. That right in there. Strange that it survived. But probably going to need a lot of rework in this area. Ugh. Looks nasty, doesn't it? So I need to clean a little bit more. But I think I've got those components good on the other... On this other... I've got two of these donor boards, so hopefully one of them has the parts we need to fix this area as well. And on the other side... Let's see, component's going to be falling off when I flip it over. I cleaned up around the SMC. It's kind of out of focus. I had the board picked up a little. But there you can see the SMC area. Yeah, we got a lot more work to do in that area too. Just did an initial cleaning so I could see what was underneath all that junk. So that needs a little more cleaning. I wonder how far that went up under there. It always seems to make its way up under the SMC. So we'll have to look into that. But that's where we are. It's a cleanup job right now. But hopefully we have the parts. Well, where are we now? Let me give you an update. I have, of course, got the the PP3V42 area cleaned up. I've done some trace repair around the SMC, right in this area, where we had some resistors that had come loose, and some traces eaten into. So, and other than that, I have went ahead and removed the LCD connector and taken the fuse out. The fuse was still good. It had not blown. I'm not sure how, but there was corrosion like all up inside the connector, the LCD connector, and some of the pins were eaten into, so I knew it had to come off. So to avoid the possibilities of any kind of shorting or anything going on, I went ahead and removed the LCD connector. It's going to have to be replaced anyway. So where are we? We're at the point of testing to see if the PP3V42 will come up at least. So, not sure how I'm going to do this with one hand holding the camera. I'll go ahead and let's just see if we get a charge light. I can get that to snap on there. Okay, why don't you want to snap on there? There we go. All right, we're in there. I've got my supply set up. I want to enable it and just see if I get a charge light now. That really should tell us if the PP3V42 is up or not. Let's see, and nothing. She draws 3 milliamps, does nothing. Well, that's disappointing. Let's see, I do have all these cables connected, right? And I've got that one underneath there. So, that was rather unexciting. Let me do some checks and see if I'm getting anything to the PP3V42 into it and out of it. Okay, I think I found the problem with the PP3V42. Here's the schematic. I have my DC coming in from the my power supply here through this diode array into here, and all that was fine. I've got it for 16.5 volts, and that's there, and that's fine. Then I noticed the shutdown signal, which is low, a shutdown on low, is low. And follow that back. The only thing that pulls that up is this resistor right here, which is actually a 0 ohm resistor tied back to that main DC in. And that resistor is just gone. It's not there. I guess I may have knocked it off with the toothbrush, but it's not there now. And this is a no stuff, so this doesn't matter here. And that's a no stuff. In other words, it's not on the board. They never put it there from the factory. So I'm going to take that 0 ohm resistor off of a donor board, stick it there, and hopefully we shall have PP3V42. Here's the board layout. You have DC in coming in here, and let's see, it goes, yeah, it comes in here, and let me click on this other one so you can see. DC in's coming here on pin 6, and you can see it also goes over to R7080. That's a resistor that's missing. And so the other side of that is what goes, well, there's probably, well, that capacitor is a no stuff also. It goes back to pin 8, which is the shutdown command. And like I said, this resistor is simply not there. And it's going to have to be, or this thing's never going to run. The shutdown's going to be low all the time, and she'll never run. So that's why I'm going to move this one jumper over. Move that, well, I call it a jumper. It's a 0 ohm resistor, basically a jumper. I'll move it from a donor board, stick it on there, and then we'll see what happens. All right. Please forgive my hot air station cooling off over there. It'll cut off in a second. I have installed that little 0 ohm jumper, which is, if I can point to it, over here, right in this area. Where is it? Right there. So that's installed. I confirmed that there's a direct connection from the DC in voltage to that pin 8, which is the shutdown pin. So in theory, something should be different now anyway. All right, power supply. Let me enable it. Hey, green light. Fan spin? Well, that's a bit much, but we have a fan spin. Wow. Okay, I'm going to shut that down. I should have noticed. Let's see how much current it was drawing. I didn't really notice how much it was drawing. Oh, yeah, 400, 500, 600 milliamps. That looks like a legit trying to boot something. Excellent. I wonder, just for S's and G's, shall we say, what if I stuck a USB drive onto this thing? The one I've got here with my Ubuntu install on it. Is this the, I can't remember which one it is now. Is it this one? Wow. Nope, it's this one, I think. It's this one. Too many thumb drives laying around. Let's just see. I'm just curious if it will get an activity light. And try to boot off of it. This is hard to do. Is that in there? Forgive me a second. Oops. No, it was not in there. All right. Probably should edit that out. Okay, I have a drive in here. I need to flip this over, though, where we can see the activity light. Maybe turn some lights off. And all right, I'm going to give it power. Let's see if we get some booting activity. Anything? Fans. I don't remember if this thing has a light on it or not. Oh well. Let's turn that off for now. Oh, there it goes. I did see it flash. There you go. She's trying to boot. Well, that is encouraging. Signs of life. Okay, well, I guess the next thing we need to do is get this LCD connector replaced, which I'll probably pull off of a donor. Get some lights back on. I'm going to have to do a little trace repair right in here also. I'm pretty sure that's where, that's where the LCD backlight voltage would have gone in, which is like 40 volts, I want to say. And any liquid that comes in these things just seems to seek that out. It goes right to that and just, it gets eaten away. So, yeah, we got some cleanup to do in this area. I've cleaned it up some, but it still looks kind of ugly. But new connector and some trace repair. New fuse for the backlight. And we might be able to put it back in the case. I do have that test screen. I'll hook that test screen up rather than putting it all back in the case. I'll put the test screen on it, and we'll just see if we get a backlight and maybe a folder icon. Sound good? Sounds good. It is the next day, and we are back again working on this MacBook Air board. And I have already replaced the LCD connector here, because the other one was just completely corroded. I've replaced several capacitors and ICs in here, took those off donor boards. So I've got this looking pretty good. Got a new fuse in there. Replaced some of these resistors. These are the LED return resistors, they call them. Some of those had changed value drastically. Pulled those off a donor board. And I've got my test screen hooked up. We're ready to apply power, and I just want to see if we can get some backlight and maybe a nice question mark folder. So, without further ado, let's see what goes horribly wrong. Trying to think. Okay, let's see what happens. Drawing 600 milliamps. Not seeing any backlight yet, or do I? Yep, I have backlight. You can see it bleeding out the edge there. Of course, the fan is running. We have a light there. Now we just need, I know this screen's terribly dusty. It's just a test screen. I've got the lights off, so hopefully we can see a nice question mark folder. There it is. All right, this is very encouraging. Now that fan sounds like it's running a little fast. I'm not sure if that's going to be a sensor problem or not, but yeah, it's ramping up pretty good. But then again, the keyboard and the the trackpad are not connected, so that's a couple of sensors that it doesn't see right now, and it tends to ramp the fan up when it doesn't see a sensor. All right, very encouraging. All right, I think it's ready to put this thing back in the case. See if it'll charge a battery and see if it'll boot into an OS. Well, the motherboard is back into the case. I think I got everything hooked up. We are at the point of a test to see, if it will try to boot, if it will try to charge the battery. I'm really concerned if the keyboard works, the trackpad works, Wi-Fi, and will it charge the battery? Because that battery is dead. I measured like 0.2 of a volt, so it's pretty dead. So she should really, the current draw should shoot up to like 3 amps or something if it's actually charging this dead battery. I've got a USB drive in there ready to let it boot. Let's see what happens. $700 milliamps. Oh, we got a chime. Approaching an amp current draw. I think you should start booting off that thumb drive automatically. Current should be going on up. I hope that battery survived. These lithium ions do not like being taken to zero. Okay. Ubuntu is wanting to boot up. This keyboard looks really nice. I think this is a 2018 model. I don't think it's seen a lot of use. And it had liquid damage, obviously, but the keyboard doesn't feel crunchy like it was. Maybe it didn't get poured through the keyboard. I don't know. I'll have to test these keys out, but I was expecting to have some crunchy keys going on. Current drifting over an amp now and then. Okay, we are booting. This version takes a while to boot up. Oh, it's doing a check disk. I can't say it sounds like the fan is not ramping wide open, so it may be happy. It sees all of its sensors. That's good. A lot of times with these liquid damage ones, you get damage on the trackpad and the keyboard wiring, and it loses contact with its sensor, which is mounted somewhere around in the palm area here. Probably, I think it's on the trackpad or the trackpad cable, and it'll lose contact with that sensor, and the fan will just go wide open. I wonder if it slow charges the battery to begin with. We may have to actually put a meter on it and see if it's putting anything into that battery. Well, she finally finished her check disk and is fully booted, and she is up and running in Ubuntu. And looks good. The Wi-Fi has connected. Saw my access point. That's all good. Keyboard seems good. Touchpad is good. I did measure the battery voltage while it was trying to do the check disk, and it's like 5.8 volts and climbing. So it is charging the battery. That's good. So I think we are almost done. I got some more cleanup to do, as I can show you. Here's the bottom case. Yeah, that's nice. So I got a little more cleanup to do to this thing, but overall it's looking good. Looking like we've got a successful fix here. We're drawing about 1 amp, spiking up every now and then. So that's it for this one. I think we're going to be all right on this one. I hope you enjoyed it. If it was at all entertaining or educational to you, please give me a thumbs up, and I will see you in the next video. Catch you next time.